So children, we meet again in part 3 of chapter 6, squares and square roots. In the first part, we studied the properties of a perfect square number. After that, in second part, we studied some interesting patterns. We studied two patterns. One was the addition of two consecutive triangular numbers and to find the numbers between the two consecutive square numbers. Now we will study some more properties in this part 3. So let's start. Now adding of odd numbers. You know what are odd numbers, isn't it? 1, 3, 5, 7, 9, 11, 13, 17, 13, 15, 17 and so on, isn't it? They are all odd numbers. Now let's watch this. 1. 1 is the odd number and that 1 is equal to 1 square. Adding of the consecutive first two odd numbers, 1 plus 3. So sum of the first two odd numbers is 4 and that is 2 square. Just observe, okay? 1 plus 3 plus 5. Sum of the first three odd numbers, which is equal to 9, that is equal to 3 square. Sum of three odd numbers, 3 square. Sum of four odd numbers, 4 square. Sum of 5 odd numbers, 5 square. Sum of 6 odd numbers, which is 36, 6 square. So similarly, sum of 7 odd numbers, first 7 odd numbers, not any 7. First 7 odd numbers will be 7 square. Sum of first 8 odd numbers will be 8 square. So sum of n odd numbers, first n odd natural numbers will be n square. I hope I am clear with this. Yes. So let's move to the next part. Now, on basis of this, how to find out whether the given number is a perfect square or not. Now, on basis of sum of the odd numbers. Now, let us find out whether the given number is a perfect square or not. Let's consider 25. So, what we will do is, if 25 is we will subtract successively 1, 3, 5, 7 and 9. How? You didn't get it? When we will solve stepwise, you will understand. Now this number 25, I want to find out whether it is a perfect square or not. We know that it should be the sum of the first 5 odd numbers, isn't it? It is 25. Now, but suppose we don't know. This we know, but we don't know the given number is a perfect square or not. Then always, yes, we see the last digit 5. But that is not enough. Sometimes the number ends with 5, 35. It ends with 5, but it is not a perfect square. So, to find out whether the given number is a perfect square or not, what we will do is, from 25, we will successively subtract the odd numbers in order. That means in the first step, excuse me, in the first step, what we will do is from 25 we will subtract 1. So we got 24. Now from 24 we will subtract the next odd number, that is 3. So 24 minus 3 is 21. Then from the next we will subtract the next odd number from 21. So from 21 I will subtract 5. So that is equal to 16. Then from 16 I will subtract the next odd number and that is 9. So 9 minus 9 is equal to 0. So this means 25 is equal to, see, the last step we should get the remainder 0. If we do not get in the last step the remainder 0, then it is not a perfect square because the sum will not be equal to the given number. That means 1 plus 3 plus 5 plus 7 plus 9 will not be equal to the given number. But here the number is 0. So 25 is equal to 1 plus 3 plus 5 plus 7 plus 9. So 25 is a perfect square. Let's consider another example. That is number 38. We know that it ends with 8, so it is not a perfect square. But we have to show that it is not a perfect square. So here successively I will subtract the odd numbers. 38 minus 1 is equal to 37. 37 minus 3 is equal to 34. 34 minus 5 is equal to 29. 29 minus 7 is equal to 22. And 22 minus 9 is equal to 13. 13 minus 11 is equal to 2. And 2 minus 13, which is equal to minus 11. Now minus 11 is not, this is not equal to 0. So this shows that we are not able to express 38 as the sum of consecutive odd numbers starting with 1. So also 38 is not a perfect square. This shows that 38, we are not able to express it because here it is not an successive odd number. So minus 11 minus 13, after that I should be getting 0, but I am not, I will never get 0. I will get the answer in negative numbers. So 38 is not a perfect square. Let's do some examples of this here. So first you have to remember this statement. If a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. Now as I told you, let's solve some example based on this. Find whether each of the following number is a perfect square or not. So I will take the first one as 121. So 121, I will start subtracting from 1. So 121 minus 1 is equal to 120. The next number I have to subtract is 3. So 120 minus 3 is 117. 117 minus 5 is 112. 112 minus 7 is equal to 105. 105 minus 9 is equal to 96. And 96 minus 11 is equal to 85. 85 minus 13 is equal to 72. 72 minus 17 is equal to 57. 57 minus 17 is equal to 40. 40 minus 19 is equal to 21. I am taking the successive odd numbers. After 13, 15, after 13 I am subtracting 17, then 19 and the next number is 21. So 21 minus 21 is equal to 0. Thus 121 is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11, 13, 17, 15, 17, 19 and 21. So therefore 121 is a perfect square. It is because there are 11 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So that is equal to 11 square and that is a perfect square. Let's take the next number 55. 55 minus 1 is equal to 54. 54 minus 3 is equal to 51. 51 minus 5 is equal to 46. 46 minus 7 is equal to 39. 39 minus 9 is equal to 30. And 30 minus 11 is equal to 90. And 19 minus 13 is equal to 6. And 6 minus 17 is equal to minus 11. Thus, 55 cannot be expressed as the sum of consecutive odd numbers. So, 55 is not a perfect square. This is how you will do it. Now here, 81. Similarly, after subtracting the 1, 3, 5, 7, 9, 11, 13, 15 and then 17, I get 0 at the end. That means 81 is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 17. Therefore, 81 is a perfect square. So you will do in homework question number 4 and question number 5. You have to do it in a similar way. Let's see the next type. Now, the fourth one. A sum of consecutive natural numbers. That means a given number. How will you express the given perfect square number as a sum of consecutive natural numbers? See, here you are given one example. 3 square is equal to 9. So, what you do is 9 minus 1 upon 2 will be the first number. 9 minus 1 upon 2, 9 minus 1 is 8. 8 upon 2 is 4. And 9 plus 1 upon 2. 9 plus 1 is 10. 10 upon 2 is 5. So, we can express it as 4 plus 5. This is the method. So, now 5 square, 25. 25 minus 1 is 24 divided by 2, which is 12. And 25 plus 1 is 26 divided by 2, that is 30. So 12 plus 30. So 7 square is equal to 49, which is equal to 24 plus 25. So we have to express the following as the sum of two consecutive integers. How you are going to do the sum? First one is 12 square. So first you write down the square of 21, which is 441. So therefore 441 minus 1 upon 2, which is equal to 440 upon 2, that is 220. Next you add 441 plus 1 upon 2. So that is 442 upon 2, that is 221. So thus 21 square is equal to 441, which is equal to 220 plus 221. Similarly, 13 square, 169. So 169 minus 1 upon 2, which is 168 upon 2, that is 84. And 161 plus 1 upon 2, that is equal to 170 upon 2, and that is 85. So 13 square is equal to 169, which is equal to 84 plus 85. Similarly, you will do question number 3 and question number 4 by yourself in your notebook. You will do all these question of the previous type, that is third type, and also this. Everything what is given in this video you have to write down, plus the homework which is given, and you have to do it by yourself. That is just the practice. In same way you have to do it. 11 square and 19 square. Okay, see you in the next part.